Hello everyone, and welcome to today's math lesson with Everyday Seminar. Before we move on to today's topic, let's go through the solution to last week's quiz, last week's question. Now, on our same example that we used, highlight the solution set for A union B union C minus or take away A intersect B. So let me just quickly draw that right here. We have A has 1 and 2. Set A has 1 and 2. Set B includes 2 and 3. And then we had a set C outside. And set C only had 4 inside. Therefore, A union B or A plus B, all of A, all of B, and all of C minus or take away A intersect B. So A union B union C equals to a set of 1, 2, 3, and 4. And then we minus or take away A intersect B, which includes elements of only 2, right? Only 2. So all of that minus 2, right? A in union B. All of this, take away that. So the solution is everything outside. You can color. Let me just get a new, everything except for 2. So the answer is 1, 3, and 4. Okay, let's move on. Our topic for today, we're going to continue on with probability theory. And today we're going to do, I guess, 2 main topics, key topics under probability theory. One of them is conditional probability, and the other key field we're going to cover is Bayes' theorem. Okay, let's move on. So our key terms for today, conditional probability, Bayes' theorem, and we'll be dealing a lot with tree diagrams. And here's a picture of Thomas Bayes, one of the most important statisticians that ever lived. Okay, our first topic, conditional probability. Conditional probability is a chance or the probability, okay? Just for your information, when we say chance, it's the same as saying probability. So the chance or probability of an event given that something is true. Now here's a very important notation, P bracket A slash B. What this means is, what is the probability of A, event A, given that B is true? So what is the probability of A given that B is true? For example, what is the probability of becoming a doctor if you are a female? Okay, that's an example. More on this soon. Useful applications of conditional probability, data analysis, statistics collection, and diagnosis of medical conditions, as we'll see later on. Let's move on. Okay, now let me just briefly introduce the next topic, a Bayes' theorem. This is one of the most important theories in maths, in statistics especially. Now, here's the theory, this is how it's most commonly written. The probability of A, given that B is true, is equal to the probability of B, given that A is true, multiplied or times the probability of A, all of that divided by the probability of B. Now this is very similar to what we'll call the conditional probability formula, which uses, basically it uses the simple union intersection from Venn diagrams. So here, the probability of A happening if B is true, or when B is true, is equal to the probability of A intersect B over the probability of B. So it's that over B here. This is A intersect B. Okay? That's equivalent to that. Okay, let's move on. Okay, let's start off with an example. This will really help you. Now, Imagine that your retail business is considering holding a sidewalk sale promotion next Saturday. Past experience indicates that the probability of a successful sale is 60% if it does not rain. This drops to 30% if it does rain on Saturday. A phone call to the weather station finds an estimated probability of 20% for rain on Saturday. So the question is, what is the probability that you will have a successful sale? Now let's look at the variables. Okay, so here we have, we're going to use R if it rains next Saturday, N if it does not rain. Okay, R, N. A, we're going to use A for a successful sale, sorry. And U will mean an unsuccessful sale. R, N, A, U. Now, firstly, let's go back here. So the probability of rain is 20% that it will rain. The probability of a successful sale is 60% if there is no rain. And the probability of a probability of 60% if it does not rain, and a probability of 30% if it rains. Okay, successful 60% with no rain, but if it rains, the success goes down 30%. More on this shortly. So, looking at that, we're going to explain it again here, Venn diagram. So, the probability of a successful sale, given that it does not rain, equals to 0.6, 60%. And the probability of success if it rains is 30%. Okay, as we showed you on the past slide. Now, what we also know, we were given three numbers, 60, 30, and 20. So we know that the probability of rain on Saturday is 20%. So in addition, we know that R and N are complementary events. N equals RC. Therefore, this 0.2 plus the probability of no rain should equal to 1. So rain, 20%, so no rain is equal to 0.8 or 80%. Okay, as shown here. 20% it'll rain, 80% it won't rain. Probability of success, 60% if it doesn't rain, 30% if it rains. And our goal is to find probability of A. What is the probability of A, which is success? What is the probability that we will have a successful sale? Okay, let's see what happens now. Okay, now let's look at this tree diagram. We'll call it method 1, a way to solve our problem. Okay, we're going to look at it using something that looks like tree branches, right? Now, first thing to remember, each branch of the tree represents the intersection of two events. So on Saturday, it either rains or it doesn't rain. If it rains, how much percent it can also become successful, unsuccessful? If it doesn't rain, what's the percentage of success? Percentage of you unsuccessful. Now, here we have the probabilities. These are the events, conditional probability, and the probability, first line of probability. So on Saturday, remember our numbers before, 20% chance it will rain, and 0.8 or 80% chance that it won't rain, no rain, N. Now, if it rains, success is 0.3, 30%, therefore, unsuccessful becomes 0.7%. 70%. Now, we also knew that if it did not rain, N, success would be 60%. Therefore, 1 take away 0.6 equals 40%, that it'll be unsuccessful. Now, we can look at the events here, R union A, so R and A, and then we can work out what is the chances of success with rain. Okay, right there. And this one, R intersect U, so unsuccess given rain, N intersect A, so the probability of success given no rain, and the last one, N intersect U, what is the probability of being unsuccessful given no rain. Okay, so the first one, we have the probability of R, probability of success given no rain. The total probability we have there for the success with rain is 0.06. 0.2 multiplied by 0.3. Now, given rain, our probability of being unsuccessful is the probability of rain, 0.2. Then you multiply it by this 0.7 here. So you do that for all of these branches, 0.8 times 0.6, and finally 0.8 times 0.4. So you'll notice 0.06 plus 0.014 plus 0.48 plus 0.32, all that equals to 1, or 100%. Okay? Okay, let's move on and see what we get. Therefore, remember our question was, what is the probability of success? Okay? Rain or no rain, it doesn't matter. What's the probability of success? So, using our formula, probability of success equals the probability of R intersect A plus the probability of N intersect A. So what we've done is we've taken the probability of success here with rain, and we've also taken the A here, probability of success without rain, 0.48 and 0.06. So we add the 0.06 plus the 0.48. Therefore, we get 0.54, which equals to, 54%. So we can say the chance or probability of success based on the chances or probabilities of rain or no rain, it doesn't matter, is 54%. Therefore, 54% is greater than 50%. So if I were to think, should I have a sale? The answer is yes, I am going to have a sale on Saturday because there is a higher chance of success. 54% success, so 46% of fail. Fail, success. Rain or no rain. Okay. Now let's have an extension of example 1. So in example 1, we just showed you P, probability of A, probability of success. What if we wanted to know, instead of the probability of success given rain, what if we wanted to know the probability of rain given success? So what's the probability of rain if we are successful? Now, the conditional probability that it rains given that the sale is successful, how do we calculate this? Now the answer is we can use conditional probability formula, which is basically the same as Bayes' theorem. Okay? Probability that will rain being successful is equivalent to the probability of rain intersect A, or success, divided by the probability of success. Now, if you extend this, what you'll get from our past Venn diagram is we'll get that formula, which you can also, do you remember Bayes? So let me Bayes' formula, PA over R, is equal to PR over A multiplied PA over, what's this one? Probability of R. So what we can do here is we can make that the subject, move that here, that becomes probability of success given rain, multiplied by the probability of R, and then we divide all that by the probability of A. And then that will equal to the probability of RA. Can you see what we've done? We've moved everything here to that side, and then we get this formula. The probability of rain given success is just the opposite. Probability of success given rain multiplied the probability of rain over the probability of success. Okay, that's using Bayes' theorem. And we can also put it in the conditional probability formula, and then we get 0.3 multiplied by 0.2 on the top over 0.3 times 0.2 plus 0.6 times 0.8, which equals to 0.1111, which equals to basically 11%. Okay, so not only can we calculate P, probability of success with rain, we can also do probability of rain given success. Okay, let's move on. So again, the event A is the union of event R intersect A and event N intersect A. So the probability that we wanted of A is a success with rain and success without rain. Okay, this is using, remember what we did last time, a Venn diagram. This is our second method. Okay, let's move on. Now, the probability of success, that's what we wanted to answer. And we're going to use these Venn diagrams and Venn notations. Remember we did that before, intersect and union. So we need the probability of rain with success and the probability of no rain and success. So we recall from conditional probability that we just did previously that PR intersect A is equal to probability of R minus the probability of success given rain. Okay, go back and have a look at Bayes' theorem and the conditional probability theory. So therefore, the probability of N, probability of no rain with success, is equal to the probability of N multiplied the probability of success and N, which is basically 0.8 multiplied 0.6. And here, using the probability formula here, we can take this number, PNA, and we add PRA, intersect A, and we get the same answer, 54%. Okay? Okay, and finally, I prefer the tree method. Actually, I think it's much more simpler. So let's examine the probability of success given rain. Consider PA/R, the conditional probability that sale is successful given that it rains, using conditional probability formula. Okay, here's our formula here, similar to our Bayes' theorem formula. Notice that should be probability of RA multiplied by the probability of A. Okay, in Bayes' theorem, that part. So this is equivalent to taking those stars over there and dividing it by the probability of success with rain. Okay, that section divided by that on the bottom here. Okay, and finally, here's a question. It might be relatively hard, okay, but we'll work on it carefully. 10 out of every 1,000 women aged 40 who participate in a routine screening have breast cancer. So 10 out of every 1,000 women, we'll draw a woman like that, they have breast cancer, for example. Now, 800 out of 1,000 of the women with breast cancer will get a positive test. So positive test for 800 out of these, 800 out of 1,000 will get positive. And 95 out of 100 women without breast cancer will also get positive tests. So 10 out of 1,000 will get breast cancer, and we also therefore have about 990 over 1,000 with women with no breast cancer. Okay? And those with no breast cancer, we have 95 out of 1,000 who will get a positive test. Therefore, 905 will get out of 1,000 will get a negative test. Therefore, people with breast cancer, 800 out of 1,000 get a positive. Therefore, 200 out of 1,000 get a negative. Now, the question is, if 1,000 women in this age group take a routine screening, what fraction or what percentage or what is the probability of women with positive tests who will actually have breast cancer? So the question is, what is the percentage probability of women with positive tests how many of them will actually have breast cancer? Probability of those with breast cancer given a positive test. So here are some clues I've done for you. This is what you call, where is it? 800 will get a positive. So this is a false negative. This is what we call in English a false negative, which means it's not true. So these women, it shows a negative test, but they do have breast cancer. And here is what you call a false positive. Okay? False positive. Which means it says they have breast cancer, but actually they don't have breast cancer. Anyways, we'll talk about this more next time. Thank you for joining us today with Everyday Seminar. Hope to see you next week. Have a good day.